Okay, this is a short video to help you understand what we're talking about when we're talking about power functions. The basic power function is looking like this, and we want to know what happens when K and P changes. Well, first off, we need to look at the different cases of what's going on. First off, if P is odd and it's positive, and we have several things going on here, K is greater than 0, this would be something like y equals x cubed. Well, this graph is going to start there and go up through like that. Doesn't matter what you put in for K. Here in this case it's 1. Doesn't matter what the power is. It could be x to the 5th or the 7th or anything that's odd. All those are going to have this same basic shape. Well, another opportunity that we have is to look at one where P is even and positive, which would be something like y equals x squared. Most of us know that this is a parabola that looks like that. And again, it doesn't matter here. We can put anything in front of the x, positive. We can put any even power up there, y equals x to the 4th or x to the 6th. They're all going to have this same basic shape. Well, now we need to look about what happens when K is less than 0. This would be something that looks like this. This would be the negative of x cubed. Well, what happens now is this graph's going to go down like that, and so over here, if y equals the negative of x squared, then that's going to flip the parabola over like this. And in both of these cases, when we went down from there to there, this was a reflection across the y-axis. Alright? So, we have some more cases to look at now. We're still talking about the same basic function, which is y equals k x to the p. And now we're talking about p being odd but negative. Even negative, and we still have to look at k greater than 0 and k less than 0. Less than 0. This function, p odd negative, will have this basic shape, and like this. This would be y equals 1 over x, which is also x to the negative first power. Here, wouldn't matter. If we used negative 3, negative 5, negative 7, they're all going to look like this. On this side, if p is even and negative, that would be y equals 1 over x squared, which is x to the negative 2. This graph is going to look like this. And in this case, the axis is the asymptote. And once again, it doesn't matter if we put whatever coefficient in front, whatever power, as long as it's odd or even, these are all going to look the same. The last case is k less than 0. So this one would look like y equals negative 1 over x. And again, it flips it across the y-axis. So it's going to basically look like that. And let me fix this one real quick. Because it will not actually touch the axis. And then over here, we have y equals negative 1 over x squared, and that one will look like this. negative x to negative 2, negative x to negative 1. Same thing here, reflect y-axis from there to there. And you can see that these are the 8 basic shapes that we're going to be looking at. They're all going to be the same. Doesn't matter what k is as long as it's positive or negative. Doesn't matter what the power is as long as it's odd or even. This is the 8 basic shapes of the graphs that you're going to be looking at to help you decide if k is positive or negative, p is positive or negative, and also if p is odd or even. I hope this helps.